So let's talk a little bit now about the choice of the intermediate frequency. And as I said before, the distance between omega 2 and where the signal is going to be omega 1. And so basically this intermediate frequency is going to choose where we are with respect to omega 2. And so the question is, how do you choose omega 1 and omega 2? By the way, they both need to sum up so that this is your target center frequency, right? And so what does that mean? That means if I want to be operating at, let's say, 920 megahertz, right? And omega naught is 20 megahertz, right? Then omega 2 could be 900 megahertz. Omega 2 would not be 920 megahertz, right? Because we want to center it right there. And so if we make the IF low, we have some benefit of these components are easier to make. There's less mismatch between the phases, between the I and the Q. And so basically it's just easier to implement. So a low omega 1 would really help us in making this low frequency section in an actual radio. The challenge and the problem is that as we decrease omega, the challenge with this is that as we make the LO or omega 1 small, we move this signal closer and closer to omega 2. And so we run the problem of this actually getting, if you will, if you move it too close, it may overlap with the carrier and we would have the leak through problems we had before. And the other problem is that, remember, I need to get this filter to keep this one sideband I want. The closer it gets to omega 2, the closer the lower sideband also gets to omega 2 and the sharper the filter I need. So omega 1 ideally should be much larger, as large as I could make it, to benefit both the LO leakage and the bandpass filter. So the choice of the IF is not trivial. It really is a system trade-off between your low frequency circuitry and your high frequency filters and need for rejection of LO. So typically there's a wide range that you could choose your IF to be in any system, and you're going to make an engineering trade-off between the specific circuitry and implementation of your baseband, the quality of your filter, and your final signal desired.